there is a lot of hype over BFD, or bidirectional forwarding detection, meaning a lot of folks make it a lot more complicated than it really needs to be. Hopefully in this video I'll simplify it a little bit for you, and then we'll take a look at implementing it in some different routing protocols afterwards. So bidirectional forwarding detection allows our device to essentially detect when we have a failure on a link. So, you know, if you think about UDLD, right? BFD is a lot like UDLD in that it allows our device to detect these failures on a link, and it allows it to report back to our IGP, or it could even be an EGP, but it could be BGP as well, right? So we can just say routing protocol. It allows BFD to report back to the routing protocol and say, hey, by the way, you just lost this adjacency, you just lost this neighbor, and it allows the routing protocol to cut that link right away. So there's not a lot of, you know, we don't have to wait for the hold down time to expire. We don't have to wait for all these different timers to expire. BFD can basically inform our protocol and say, hey, by the way, you just lost this neighbor. And so if we're using BGP, for example, and maybe you have a backup path, or if you're using EIGRP and you have a feasible successor, what's going to happen is the routing protocol is going to go ahead and drop that neighbor and then go ahead and use maybe the redundant path to get around to that particular network that you're looking for. So BFD can take your routing protocols that may take you seconds to converge, and it can take that down to milliseconds, which is ideally what you want, especially in today's networks, right? I mean, we really don't want to be waiting seconds for for our devices to converge. Okay. Now, BFD is going to use two different types of packets. It's going to use what we call control packets, and it's going to use what we call echo packets. Now, the echo packets are optional, okay? So you can turn these off if you want to, okay? So these guys here, you can opt out of if you want, but I don't really recommend it. Leaving this on is really the way that it works, is really the way it should be left, because it actually works better when you have this enabled. So let me explain. The control packets here are going to use UDP, and they're going to use port 3784, okay? Now, what these control packets are basically doing is they are basically negotiating different timers, okay? Now, the echo packets are basically, I want to say in parentheses here, equivalent to your keep alives. Okay, now you are going to, these are also somewhat keep alive because you are also going to send these on a periodic level, and you know, we'll see that in the timers, right? But what's going to happen here is that your echo packets are actually going to be, when you leave them enabled, your echo packets are actually going to be what you allow UDLD. It's very similar to UDLD, and you know, if I make that mistake, because BFD and UDLD operate almost identical. Okay, so BFD is going to use these echo packets the same way UDLD basically does. So I'm going to have these two devices here, R1 and R3, for example. And what's going to happen is when we first enable this, we're going to send out the control traffic to one another. And I'm going to say, hey, I have these timers. Now, when we enable BFD, we're going to have a few different pieces in the command. So we're going to have our BFD interval. I'm just going to say int. We're going to have our main underscore RX, which is the main receive. I'll get to what they mean in a second. And then we're going to have the multiplier. Okay, now what do these mean, JP? You know, what are you getting at here? So the BFD interval is basically when we send out these echo packets. When do we send out this echo traffic? Okay, so when I go onto the interface, these control packets are basically going to be enabled here on the interface. So when I go in and I enter the command to enable this on the interface, I'm going to have to say BFD and then my BFD interval, and then so on and so on and so on. So I'll have to use this BFD interval. Now this guy here is in milliseconds, which means I'm going to basically tell R3 and R1, hey, I want you to send out these echo packets, which I'll get to next, every, you know, let's say 100 milliseconds. Okay, now I have my main receive. Now what this main receive is how often I am prepared to receive a packet from you. Okay, so So what I'm doing here is I'm going to go ahead and in my control packet that I send from R3 to R1, I'm going to say, look, my echo packets are going to come to you every 100 seconds. And by the way, just in case you are configured differently on the other end, I am prepared to receive packets from you every 50 milliseconds. I mean, ideally, if you're the admin setting this up, these guys would obviously be the same, right? I really don't see any functional reason why you would say 150. You would say, hey, every 100 milliseconds, every 50 milliseconds, or what have you, whatever you want to do, 500 milliseconds, whatever, right? But just in case you have another admin on the other side who's using BFD, you can say, look, the minimum number of milliseconds that I am prepared to accept control packets from you is going to be 50 milliseconds. Okay. Now the multiplier, let's say 3, is going to say, look, I am prepared. It's basically your dead interval. In other words, I am willing to miss 3 echo packets from you in order to declare that adjacency gone. Okay. Now these echo packets functioned very interesting. It's actually really, really cool the way that they work. In that once we turn on BFD in the interface, the next step is that we have to go onto the routing protocol. So step 1, interface, right? And then step 2, we go into the routing protocol and we enable BFD in the routing protocol. Once this happens, the routing protocol goes ahead and makes a call to basically BFD configured on the interface and says, hey, I need you to form an adjacency with this, with this connected router here that we're forming an adjacency with. And once that happens and we negotiate through the control traffic, we negotiate these timers and we come to a happy medium. Then we're going to start to send out these echo packets. And what's really cool about these echo packets is that the layer 2 destination, so the MAC address, okay, the MAC address that I'm actually going to send traffic to is going to be to the neighbor. So R3, for example, is going to send out this echo packet, and the MAC address is going to be to R1. So I'm going to be able to send this traffic to R1. Okay. However, the destination to this traffic, in other words, the layer 3 destination is actually going to be myself. So when R1 receives this traffic, he's basically going to loop this packet right back down into me. So that's how I know that we have a fully functioning link. Because BFD, which by the way is a totally isolated protocol from BGP and OSPF and all these different protocols, BFD is going to be able to send me a packet to the layer 2 destination that I specify. I'm sorry, to the neighbor rather, the layer 2, and then R1 is going to go ahead and send it back because the layer 3 destination is actually going to be me. Okay, so R1 actually sends my own echo packet right back to me, and when I receive it, everything is hunky-dory, everything is A-OK, right? If I don't receive it, then I know that there's something wrong, and when I miss 3, I'm going to go ahead and drop the BFD adjacency. I'm going to go ahead and report back to my routing protocol. So the first thing that happens, so I'm going to say a failure over here. So on fail, okay, the first thing that happens is BFD is torn down. Okay, so once we tear down the BFD adjacency, then what's going to happen is BFD, okay, notifies the protocol, whatever protocol we're using. So that could be EIGRP, that could be BGP. In fact, I think you can have up to 100 different BFD instances running on the same device. I forget exactly the limit. I really don't think you'll ever run that many, but hey, you never know. So once this happens, basically the third step is that the protocol is going to tear down the adjacency. Now we have the protocol tear down. Okay, and so BFD actually enables us to through this process here, enables us to very quickly tear down an adjacency, and we can do that because we've gone ahead and set these timers. So let's get a BFD session going between, let's say, router 2 and router 4. What we'll do is we'll go ahead and use named mode here, and we'll use classic mode on router 4. So let's go and get that. Let's get that going first. So we'll say config T, router EIGRP. We'll just say 14, EIGRP router ID 4.4.4. And we'll go ahead and just say network all quad zeros just to enable it everywhere. We'll do the same on router 2. So config T, router EIGRP, we'll just call this, and actually we'll call this BFD. And we'll say address family IPv4, autonomous system 14, EIGRP router ID 2.2.2, and we'll say network all quad zeros. So we'll wait for EIGRP to come up. We'll say do show IP route EIGRP. Now we have two EIGRP adjacencies, so let's shut down Ethernet 02. So you can see we have two adjacencies came up, and we have this one here on this network. So let's shut that down. So we'll say interface E02. We'll just shut down the actual interface, and we'll say interface E02. We'll shut this guy down so we don't have any issues. Do show IP EIGRP neighbor. Okay, so we have a neighbor between router 2 and router 4. Now what I want to do is I'm going to say interface E01, and I'm going to shut this guy down. But before I do that, let's clear the screen here on router 4, and let's actually see what happens when we shut down this interface. So we shut down the interface. Interface goes down, EIGRP goes down. Let's check router 4. Take a look at what happens. Because we still have reachability to that interface, because the interface is still up, we have not dropped our EIGRP adjacency yet on router 4. You can see here that router 2 has already dropped it, and now we can see the whole time actually expire. Now, you could go in and you could tweak all the EIGRP timers to help this be a little bit faster, but bidirectional forwarding detection is really what helps us to make this process a little bit more proficient, if you will. So let's no shut this guy. We'll wait for this to come back up, and then we'll configure BFD on both of these routers. So while we're waiting, we're going to say, let's say debug BFD, and we'll just go ahead and say packet. So we'll kind of debug everything, and we'll do the same thing on router 2. So we'll say do debug BFD packet. This way we can see some of those adjacencies come up. Now, in order to do this, we have to enable BFD globally first. So we're going to do that on both sides. We'll do that first. So we'll say exit, and I'm going to say BFD, and the next thing I'm going to do is say interval BFD. Why did you not do that? Oh, right, under the interface. Duh. Interface E01, and we're going to say BFD, and now I'm going to go ahead and say interval. And I'm going to say milliseconds, we'll say 50, we'll set this to the bare minimum. So we'll say minimum RX is also going to be 50. And we'll go ahead and set our multiplier here to 30. By the way, let me actually question mark my way through just so you guys can see the options. So we'll say the multiplier, and we're going to say this guy is going to be, actually let's say 3. All right, so we'll say BFD interval 50, minimum RX 50, and the multiplier is going to be 3. Let's go over to router 4. And I'm going to say interface E01, and I'm going to pop in the same exact configuration. Now, we have the debugs running on both sides, but we see that we haven't actually activated this yet. We haven't actually turned it on, if you will, and we need to go ahead and do that underneath the actual process. Now, in EIGRP, you do it two different ways. Essentially, you can have two different options. So let's go in and we'll say router EIGRP, I think this was 14. I'm going to say BFD. And I can either say the individual interface or all interfaces. And this is what I meant by two different options. So you can really pick what you want here. So I can say Ethernet 01. And at this point, I'm now going to activate BFD on my interface going towards router 2. All right, let's go ahead on router 2. And I'm going to say do show run section router EIGRP. And I'm going to go into my address family. And if I take a look here, I don't have any option for BFD. Let's go into a topology base. And let's take a look. Do I have any option here for BFD? And the answer is no. The interesting thing here is that in EIGRP named mode, the way that we would do this is actually under the address family interface, which is where a lot of people get confused. Now, you can either pick, just like in the global process, so just like here, let's say do show run section router EIGRP, where we had the option here to do it under an individual interface or under all interfaces. So if I said BFD all interfaces, same concept here with named mode, except you would do either address family with the individual interface. So I might say E01, or I could say address family default, and that would be the equivalent of all interfaces. All right, so I'm going to say E01, and all I'm going to do is say BFD. At this point, you can see that we have some BFD traffic going back and forth, and you can see that we actually have an up message here. So we have init, and then we had up. So if I say show BFD and I select neighbors, we should see that we have an up status between our router 2 and router 4. Right? Same thing if I go over to router 4, we had a down state, init, and then we have an up state. gives us the neighbor. So here's our receive and here's our transmit. If I say do show BFD and again I choose neighbors, it's going to tell me that I have an up state, right? So as of right now, I have a BFD session that's actually up and running. I can also say show BFD summary, and that's going to give me some, that's going to give me some additional information. How many sessions am I running total? How many up? How many are down? Etc. Right? Now watch what happens when I go down and shut this interface. So I'm going to go back into config, interface E01, and I'm going to go ahead and shut this guy down. And watch, immediately after I shut this guy down, we see a debug message. So we transmitted this message of admin down to router 4, and you can see that the minute we shut that guy down, echo function failure, administratively down. So you can see that we detected through BFD immediately this interface down failure, and immediately EIGRP was able to kick in. You can see here that we received a message that said BFD peer down notified. So we were able to instantly let our neighbor know that we were down. When we come back up, we should be able to form an EIGRP adjacency, or over its regular. So you can see here we have new adjacency comes up. So BFD actually helps us to really speed up this process of detecting when we have a failure with our particular neighbors. If you're running EIGRP or really any protocol on your network, if you have the ability, you should absolutely run BFD.